So the first thing I'm going to do is create a plane and just kind of get the scene set up. Okay, now that we have a plane up, just going to call this ground. And now we can start actually setting up the player. So what we're going to do is create a capsule, bring it up to 0 on the y-axis, and call it player. I'm going to give it the red texture, and we're just going to get rid of this capsule collider. Okay, we're going to grab the main camera and put it onto the player, reset, and give it a Y of around 0.8. Okay, so now that we have the main camera on the player, we're going to grab this model. It was made by Jovis, and if you want to know how to make this exact model or where to get it, I'll leave a link in the description in order for you to go watch this tutorial. When you drag it in, it might be a little bit bigger. Just go ahead and give it a scale factor of 0.5, and it'll be this size. What you might notice and what you might not like is that there is no arms attached to this gun. So what I'm going to do is I'm going to use a old model that I made back in the day, and if you'd rather use this one over Jovis's model, just go ahead and look in the description. I'll give you the link straight to it, but I'm going to show you how to use Jovis's model with my hands. So go ahead and grab my hands and unpack the prefab. You can delete the mag, handle, and front metal, and as you can see, the AK is entirely gone. So now grab the AK and drag it onto the player arms. Go ahead and give it a position of -0.05, -0.025, and -0.1. As you can see, it almost perfectly fits into the hands. Okay, so now for the hands themselves, we're going to go ahead and put it onto the main camera, scale it down 0.75. And give it a position of 0.5, -0.4, 1 on the Z, 1 on the rotation, and 0.75 for each of the scales. Now for all the values I just gave you, it doesn't really matter the positioning of it too much. If you prefer the V model to be up here or like this, that's perfectly fine. What you might notice is the camera is actually clipping into it, so you want to click the camera, go to where it says clipping planes, and change it to 0. Now you can actually see that on the camera the gun goes all the way to the camera. Okay, so now into the tutorial part. First thing you want to do is you want to go onto the gun. Let's just go ahead and call it AK-47 and add a component called gun controller. So the first thing we're going to actually do is get rid of all of this, and we're just going to do the default variables that are going to differ from every single gun. So we're going to go header, gun settings. What kind of variables does a different gun have from each other? They all have different fire rates, so we're going to do public float fire rate. They all have different clip sizes, so public int clip size. So we're going to go public int reserved ammo capacity. And since these are static things that won't change throughout the code, now we want to create the variables that will actually change, such as how much ammo there is in the clip, how much he has extra, and just stuff like that. So we're going to go ahead and go variables that change throughout code. We're going to do bool can shoot. We're going to go int current ammo in clip, and int ammo in reserve. And in the current state, these things don't actually do anything, so let's go ahead and give them values inside the start function. So we're going to go current ammo and clip is equal to clip size. Then we're going to go ammo in reserve is equal to reserved ammo capacity. And finally, we're going to go can shoot is equal to true. Okay, so what we're doing here is we're assigning these variables, but we're not actually using them at any point. So we're just going to set up a very simple shoot function. So we're going to go void updates. The reason we want to do this in the update function is because we're detecting input. So we want to go if input.get mouse button 0. So if the player is currently holding left mouse button and the player can shoot and the current ammo in clip is greater than 0, then we want to execute this code. So whenever the player shoots, we want can shoot to be false. We want current ammo and clip to subtract 1. And finally, we want to start what's called a quarantine. So quarantines are cool because they actually run off of main thread, which means that we can work with timers and different things without it actually freezing the Unity game. And we're going to be using it in this instance in order to shoot the gun. So we're going to go start quarantine shoot gun. Now to actually create a quarantine, we want to go IE numerator. So as you can tell, IE numerator doesn't exist, so what we want to do is do using systems.collections up here. I think I removed it earlier, but just add it up there if you don't have it. Call it shoot gun. And what we're going to do is, since this isn't taking up the main thread, we can actually do yield return new, wait for seconds, and then we want to wait the fire rate. So what this is going to do is it's going to run this function, and then it's going to wait however long our fire rate is, and for this instance it's 0.1 seconds. And then we're going to tell the player, hey, you can shoot. Okay, so if we go back into the editor and go to debug mode, we can hit play, and you could see the player can shoot. The current ammo he has in his clip is 30, and he has 270 bullets in reserve. Now if we go into the game and hold left click, every 0.1 second it'll remove 1 bullet from the clip. And you can see it goes all the way down to 0 and stops. So what you might notice is that once you hit 0, we actually have no way to reload the gun, so we're going to implement that right now. We're going to go inside the update function and simply add else if. So we're going to check if the player hit the R key. So if he hit R and the current ammo in clip is less than the clip size, meaning that, let's say he has 30 bullets in his clip and the maximum amount of ammo he has in his clip is 30, he won't be able to reload his gun. We also want to check if the ammo in reserve is greater than 0. So what we're going to do is we're going to create a integer, and it's actually going to hold the amount that we can add to the clip. So we're going to grab the clip size. For example, the AK is 30, and we're going to subtract how much ammo there is currently in the clip. So let's say our clip size is 30 and there's 27 bullets. This will mean that we need to add 3 bullets to the clip. So what we're going to do is we're going to go if amount needed is greater than or equal to ammo in reserve. We're going to go current ammo in clip plus equals ammo in reserve. And then we want to subtract what we just added from the ammo in reserve. And let's say that the amount needed was actually less than the amount in the reserve. We're going to go else if. We're going to go else current ammo in clip equals clip size. And finally, ammo in reserve minus equals amount needed. Now that we're back in Unity, we can hold left click. You can see there is 22 bullets. Hit R and it'll remove 8 bullets from the reserves and add 8 bullets to current ammo. If we go down to 0, if we hit R, 30 bullets are removed. And if we keep hitting R, nothing happens because this clip is full. Visually, there isn't anything telling you, hey, I'm shooting a gun. So what I'm going to do is I'm going to actually make muzzle flash. The way we're going to do this is by going to the AK-47, going to UI, and adding an image. So what you can see right now is that the image is displayed over his main camera. And what we want to do is we want to actually give it a point in world space. So the way we do this is by going to the canvas and setting render mode to world space. Finally, we can reset its position, give it a width of whatever you want. I'm giving it 10. And now you can see that this image now renders in world space. It's right in front of the player. So I'm going to give it a width of 0.1. Let's try 0.25 and a height of 0.25. I'm going to grab the image, put it in front of the player's muzzle, and as you can see, that's actually all we need to do. So now inside of code, we want to go back to the top and create a comment saying muzzle flash. And what we need is we need to go to this canvas and we need to pull out this image component. So we're going to go public image and call it muzzle flash image. You can see that we don't have the namespace, so what you need to add is unityengine.ui in the top. Okay, so on top of that image, we actually need the sprites of all the muzzle flashes that we're going to be using. So we're going to go public sprites, and we're going to call it flashes. So what we're going to do is right when he shoots the gun, we're going to start another quarantine, but this time we're going to call it muzzle flash. Now if you remember, the way that you create a quarantine is by going IE numerator and calling it your quarantine name. Okay, so what we need to do is we need to give this image a sprite, give it the alpha of 255, and then 0.05 seconds later we want to give it an alpha of 0. And the way we're going to do this is by going muzzle flash image dot sprite, and we're going to set it equal to flashes. We're going to give it a index of random dot range, between 0 and flashes dot length. Then we're going to set the alpha color to 255. So we're going to go muzzle flash image dot color and set it equal to a color dot white. Then after we give it a color in the muzzle flash, we're gonna yield return new, wait for seconds, and then we're gonna wait 0.05 seconds. So after 0.05 seconds has went by, we want to actually get rid of the image and give it an alpha of 0. So we're gonna go muzzle flash image dot sprites is equal to null, and muzzle flash image dot color is equal to new color 0000. So that's actually all we needed to do. We can go back into Unity, and if we go to the AK-47, we can see that we require an image and some flashes. So we're going to drag the image into the image, and let's call this muzzle flash. And we need to put in some sprites. Okay, so I have my images, and we're going to go ahead and select all of them and give them a texture type of sprite. Okay, so go to the AK-47, press this little lock here, select all of your sprites, and drag it into the flashes. So now if we start the game, you can actually see that as we shoot the bullets, different muzzle flashes appear. The next thing I actually want to do is I want to be able to aim the gun. So we're going to go to Visual Studio and we're going to create some new variables. This is going to be for aiming. We're going to do a public vector3, call it normal local position, a public vector3, call it aiming local position, and then a public float called aim smoothing. We're going to give it a value of 10. Okay, so now in the update function, we're going to write determine aim. So the reason that it's red right now is because we actually need to create a function called determine aim. So we're going to go down here, we're going to say void determine aim. So this is going to be relatively simple. What we're going to do is we're going to store a target position and give it the normal local position, and this is what the gun's going to default to. And then what we want to check is if the player is holding down the right mouse button, then we want to change this target position. So we'll go input.get mouse button 1, and this checks if the player is holding the right mouse button, and if he is, we'll set target equal to aiming local position. Finally, we want to go vector3 desired position and set it equal to vector3.lerp. And what we need for a lerp is we need to give it a starting position, ending position, and then how long it'll take to actually get to that point. So we're going to pass in transform.local position, give it target, and we want to do it over a period of time.delta time times our smoothing. Okay, so now that we created where we want the gun to be, we want to actually assign our gun to that position. So we're going to go transform.local position and set it equal to desired position. So here's when things get tricky. What you want to do for the normal local position is assign it your default view model. So for me, it's at 0.5, negative 0.4, and 1. Now your aiming local position is wherever you want to put your gun whenever the player is aiming. For this specific model and this specific gun, we're going to give it a position of 0.0375, 0.24, sorry, negative 0.24, and 0.75. If we hit play, you can see it is in its default position, and if we right click, you can see it's aiming exactly in the middle of the screen. Okay, so what you notice is that while you can right click, there's no way you can look around with the player, so we're going to implement that now. What we're going to do is go back to our variables, create a header called mouse settings, and we're going to make a public float mouse sensitivity and a vector2 that'll hold the current rotation of the player. Inside of update, we'll create a function called determine rotation, and right above determine aim, we'll go void determine rotation. So inside of here, we want to get the mouse input, so we'll go vector2 mouse axis, and we'll set it equal to a new vector2. We'll pass in input.get axis raw of mouse x and input.get axis raw of mouse y. Okay, so now that we stored the mouse axis, we want to multiply mouse axis by the sensitivity, and then we want to add it to our current rotation, so we'll go plus equals mouse axis. Now we're actually changing our current rotation, but we're not applying it to our player model, so we're going to go transform dot root dot local rotation, set it equal to quaternion dot angle axis, and we'll pass in the current rotation dot x and apply it on an axis of vector 3 dot up. Now we want him to be able to look up and down, so we're going to go transform dot parent dot local rotation and set it equal to quaternion dot angle axis. We'll go negative current rotation dot y on an axis of vector 3 dot right. So this is going to allow us to actually look around, but there is an issue. Yeah, let's fix that. So the way we're going to fix this is by going to this rotation, and we're actually going to go current rotation dot y is equal to mathf dot clamp. We're going to pass in our current rotation dot y, and we're going to clamp it between negative 90 and positive 90. Now what this is going to do is when the player looks up 90 degrees, he cannot go past that, and when the player looks down 90 degrees, it will not go past that. Now if we go back to Unity, you can see it stops both 90 and 90. So what I actually want to do is add a little weapon sway whenever you look around. I feel like it'll make the game look really good. So the way we're going to do that is by going to the determine rotation function and going transform dot local position plus equals a vector 3 of mouse axis, and we're going to multiply that by a variable called weapon sway amount, and then finally divide by 1000. So we need a variable now called weapon sway amount. So what we're going to do is go to the top, we're going to go public float weapon sway amount, and I'm just going to give it a value of 10. So back in Unity, you can see that whenever the player looks around, it'll go. So I'm looking left, it'll move to the left. I'm looking right, it'll move to the right. Same with up and down. Now if you don't like this, you can actually switch the weapon sway to a negative number so that it goes in the opposite direction. I personally like that much better, and I feel like it's a little exaggerated, so I'm actually going to give it a value of -1, and I think that looks much better. So the next thing on our list is we actually want to add some recoil whenever the player is shooting. So the first thing we're going to do is go back to the top. We're going to create a comment called weapon recoil, and we're going to make a bool called public bool randomize recoil, a public vector 2 called random recoil constraints, and finally public vector 2 recoil pattern. Let's also make a comment. You only need to assign this if randomized recoil is off. So inside of the shoot gun function, we're going to add a function called determine recoil. I'm going to move this above because I prefer that. And now let's actually create a function called determine recoil. We're going to go void determine recoil. So the first thing we want to do is we want to move it towards the camera, and we can do this by going local position minus equals vector 3 dot forward times 0.1f. What this does right here is whenever we shoot, you can see the gun actually moves back, but there's no actual recoil being applied to the camera. So the way we're going to do that is by checking if randomize recoil. So if the player is wanting random recoil, we go float x recoil is equal to random dot range between negative random recoil constraints dot x and positive random recoil constraints dot x. And then now we want a random recoil on the y-axis, so we'll go float y recoil, and we'll set it equal to a random dot range between negative random recoil constraints dot y and positive random recoil constraints dot y. Finally, let's pass this into a vector2, call its recoil, and we'll set it equal to a new vector2. We'll pass in x recoil and y recoil, and finally we'll add it to the current rotation of the player. So back in the editor, you can see that there's these two vector2s here. One's called random recoil constraints, and I'm going to give it a value of -1 and +1, and I'm just going to enable random recoil. But you can see that I'm not moving my mouse right now, but the player is getting thrown everywhere. Now, what if you want to predefine your own recoil pattern? Well, the first thing we're going to want to do is change this recoil pattern vector2 to an array, and go to the determine recoil function and say else. So if randomized recoil is off, then we want to create our own recoil. And the way we're going to do this is by going int current step. We're going to set it equal to the clip size +1 minus the current ammo in clip. We also want to go current step is equal to mathf.clamp current step, and give it a value between 0 and recoil pattern.length. And since mathf.clamp is inclusive, we want to subtract 1 from the length. Finally, we want to pass recoil pattern, get it an index of the current step, and we want to add that to the current rotation. So now that we're back in Unity, I have random recoil off. Let's go to the recoil pattern, and for the sake of the video, I'm just going to give it 5 steps. The first step will move it 0.25 right and 0.25 up. And then for the remainder of the pattern, I just want it to continue in one direction, going 1 up and 1 to the right. So now you see it's a predefined recoil pattern. So that's actually it. We're done with the gun. But in order to make things a little bit more fun, I want to be able to actually hurt the enemies. So inside of the shoot gun function, we're going to go raycast for enemy. And now let's create a function called raycast for enemy. And we're just going to do a simple raycast hit. Call it hit, and we're going to check if physics.raycast. We want to go from the camera, so transform.parent.position, and we want it to go transform.parent.forward, so directly in the middle of the screen. We want it to push hit into our variable hit, so whatever it hits. We want to give it a layer mask, and the way we do this is by going these 2 arrows and then layer mask dot name to layer, and we're going to call it enemy. So we're going to go ahead and do a try catch loop. And what a try catch loop does is it attempts to perform all of the actions inside of the try, but if there's any errors throughout it, it'll jump to the catch loop. So first of all, we're going to type debug.log hit an enemy. We're going to grab that component's rigid body if we can. We're going to set the constraints to none. And finally, we're going to add force away from the player. So transform.parent.transform.forward times 500. We can go back to Unity, and inside of Unity create an object. I'm going to make it a capsule, reset its position, give it the red texture, and we're going to make a new layer, call it enemy, and we're going to assign this capsule the enemy. We also want to give it a rigid body, and if we hit play and shoot it, you can see it launches away from the player.